Let's try also another website. For example, I'm gonna go to Martin Fowler's personal website, go to the About page and copy this link. I'm gonna go here, paste it here. Let's load everything. So after it is loaded, I'm gonna ask, who is Martin Fowler? This is my question, and this is the answer. It's saying that he's an author, a speaker, chief scientist at ThoughtWorks, and also like some of his publications. Everything is from the information that was provided to it here. Hey everyone, Nariman here. Welcome to my channel. Today, together we want to build a very simple AI scraper. So before LLMs becoming popular, if you wanted to scrape a website and extract the information that you want, you needed to exactly where to go. For example, I want to get this tag from the HTML and then extract the text, and that is what I want. But with LLMs, especially if the website has lots of textual data, you don't need to do that anymore. All you need to do is to load this website and extract all the text from it and feed this information to the LLMs using techniques like RAGs. And at the end, using the prompts, you can ask any question that you have about this website from the LLM. So since we need an LLM, I'm gonna use Ollama, which offers me lots of open source large language models. So if you look at their website, you can easily install it on Mac, Linux, or Windows. And then if you go to the models, you can see that you have access to lots of open source large language models. For example, Ollama Models, which is from Meta, and many more. I'm gonna use Llama 3.2. So I'm gonna search here for Llama 3.2. And you can see all the specifications and how can I run it. Since I already installed Ollama, I'm gonna go through the terminal to run this command. I'm gonna copy it from here and I'm gonna go and paste it here and let's run it. And you can see that since I already downloaded it before, I can interact with it right away. But if you haven't installed this model before, it will pull it for you. And it's gonna take a while because these models usually have a few gigabytes of data. So now that we are able to run our own large language model, let's go back to the browser and see what is a RAG. As I mentioned before, we want to use a RAG to be able to answer questions about a certain website. RAG is short for Retrieval-Augmented Generation. And to simply explain it to you, you are communicating with a large language model. You are asking questions and you are getting answer. This LLM is actually pre-trained on some data. It doesn't know everything. It doesn't know about the weather today. It doesn't know about what is happening today in the news. And it doesn't know necessarily what is written in a certain book. So if you want to use LLMs to ask questions about a specific topic, you need to also provide them with this information. So we provide LLM with some context and then we ask our questions. And for creating RAGs, I'm gonna use LangChain. LangChain offers lots of abstractions and interfaces to work with large language models. So if I scroll down, you can see that LangChain provides you with lots of prompts, vector stores, document loaders, text splitters, and of course lots of large language models and interfaces to work with them. The other technology that I'm gonna use is a Streamlit to easily build an UI for our scraper. I'm not gonna put too much effort today to explain you what is a Streamlit and how to work with it. But if you are interested, you can watch my previous video, which I'm gonna put it up there to get more context. So let's waste no more time and go to the code. So we need these dependencies, which I put in requirements.txt, a Streamlit for the UI, and a set of LangChain dependency. LangChain itself, LangChain community, which have some tools, LangChain core as well, and of course LangChain Ollama, because we are using one of Ollama's LLMs. You can easily install these dependencies using pip. I can show you in the command line. Notice that I'm already inside my virtual env for my project. I'm gonna say pip install -r requirements.txt, and it will install all of them, or if it's already installed, it would say that the requirements are already satisfied, like mine. And let's go back to the code. Here I tried to come up with a skeleton of the project. These are the imports that I already did, doesn't matter here. But to break down the process, what we are gonna do first is to load the website. We're gonna ask the user, please provide me with a URL. Then I'm gonna load the website, and then I'm gonna extract the text from it, because there will be lots of HTML. After I have a clean text, I'm gonna split it to smaller documents. Why? Because LLMs cannot deal with large text very efficiently. After that, my documents are ready and I need to index them. By indexing, I mean we will do embeddings on it, convert it to vector, and then we will store it inside the vector store. By doing this later, we can fetch this information very quick. So maybe it would be also good to add a method here called index docs, and then give the documents. For now, I will leave it empty. So these 3 steps are necessary when we are loading a web page. Now it's time to answer users' questions. When I receive the question, I will pass it to the vector store and retrieve all the documents that I think they are related to it. And at the end that we have all this information, I'm gonna create a prompt and ask LLM that you should answer this user's question based on the context that I'm providing to you. So I will pass both user's question and the retrieved documents that we think is somehow related to this question to the prompt. And with this technique, we will get a very good response from the LLM. So let's start coding. For loading pages, I'm gonna use LangChain's loaders itself. So I'm gonna go and say loader should be, I will use Selenium URL loader because Selenium is an automation tool which load the web page inside the browser. And if the website are using lots of dynamic content that is being loaded by JavaScript, we won't have any problems. There is also another one, web loader, that does not use the Selenium. But since modern websites are using lots of JavaScript to load the contents, I wouldn't recommend you use that. So here we will pass the URL, and then here I'm gonna load the web page, and this will give us a document. A document is a wrapper inside the text that LangChain is using. So it is a LangChain class. So now that I have my list of documents, I can just return this. And this would be enough for the load page method. And also remember that Selenium URL loader is using unstructured library under the hood to give you a clean text out of this website. So I'm not gonna clean that text anymore, and I'm gonna rely on that. Now that we have our list of documents, I want to split them in chunks because I don't want to give LLMs like huge piece of text which doesn't give you any good result. I'm gonna use LangChain's text splitters to do that. You can go and say, let's say text splitter, and we will use recursive character text splitter. I'm gonna use the chunk size of 1000 and the chunk overlap of 200. And at the start index also put it as true. There is a method called split documents, which you can use. And I'm gonna pass the whole documents to it. And again, you're gonna get a list of documents as a result. I'm just gonna call it data and then return this data. So what we did here was give a bunch of documents, and if their size is exceeding of a certain limit, we will also break down this document into 2, 3, or multiple documents. And at the end, we are gonna get a list of documents again, and we are returning it. To index the documents, first, as I told you, I need an embeddings model, and then I need a vector store. So let's define those. I'm gonna define it up here. I will call it embeddings, and I'm gonna use Ollama embeddings, as I told you before. And the model that we ran before was Llama 3.2, so I'm gonna use that. This embedding will convert our text into vectors. And for vector store, I'm gonna use a very simple in-memory vector store. And I'm gonna pass the embeddings to it. There are many more sophisticated vector stores that you can look up, but for this usage, I'm gonna just use this in-memory one. So indexing documents is very easy. All you need to do is call the add documents method and pass these documents to it. What is going to be done under the hood is that LangChain is gonna give these documents to the embedding model of Ollama and get all the embeddings from it, and then store those vectors. So for retrieving documents, let's say user is asking some question from the LLM. We will call this user query, and we are passing it to this method. All we need to do is pass this query to the vector store and ask for the related documents to this question. This is possible with the method called similarity search. There is a similarity search method here. I can pass the query to it and then return all these related documents. And now that we have all the information that we wanted, I need a prompt to ask the Ollama LLM to answer the user's question based on the context that we are providing. So this prompt template is not that complicated. I actually copied it from LangChain's website itself. It's a very known prompt for building RAGs. So let's go ahead and create a template for it and copy the prompt here. I will call it template, and I'm gonna paste it here. So it's basically saying you are an assistant for question answering. Use the following pieces of retrieved context to answer the user's question. And if you don't know answer, just say that you don't know and be concise. And here we have some mustaches for question and the context, which we will pass when we receive the question and receive the context related to that from the user. And we will build this prompt using this template. I also need to define my own LLM model that I want to talk to. So I'm gonna use Ollama LLM, and I'm gonna say I want to talk to Llama 3.2 model. We are gonna create a chat prompt here. Chat prompt template from template, and I'm gonna pass the template that I showed to you. I'm gonna call this prompt, and you can create a chain from the prompt and the model like this, and you can invoke this chain using this template. I'm gonna pass the question and I'm gonna pass the context, which context should be also passed to this method. And this will be our answer. So I'm gonna return this. So now everything is ready. I'm just gonna go ahead and create our UI and connect everything together so we can see what we built. Let's first run this part and see what we are gonna deal with. I'm just saying that this is an AI crawler and we are asking from the user to enter a URL. Let's go to the terminal and clear this. And I'm gonna say Streamlit run this file, which is called AI Scraper. And now if you go to your browser, you can see that we built this UI here, very simple. And then I'm gonna copy some URL here and ask some questions. So what we need is to build a chat under this text box and interact with the LLM. So let's go back to the code. What I need is to load this web page. And then I have a list of documents, yeah? I will also split these documents. And at the end, I have a bunch of chunked documents. I can index these chunk documents. So what I need right now is a chat. Streamlit comes with a very handy and easy to use UI for chats. I can call st chat input. And yeah, I don't need that. And this will get the question from the user. So user will type a question inside this chat input and I'm gonna get it here. So I'm gonna say if there was any questions, what I need to do is first retrieve the related documents to this question. So I'm gonna go and call retrieve docs with this question. And then I have retrieved documents. I have a few separated documents. All I need to do is somehow join these together. What I'm gonna do is maybe use join with 2 new lines and then join all the page content of these documents together. So this will be my context. Now it's very easy. I just need to call answer question and then give back question and the context. And this will be my answer. So now how to show these inside the chat using a Streamlit, that's also very easy. When there was a question, I'm gonna say there is a chat message and this question is from user. And you need to show it inside the chat. So this line will show user's question. And when I have the answer, I'm gonna say show this chat message as not user but assistant, which is our LLM. So as you can see, this UI for chat is very easy from Streamlit. Now we are good to go actually, and we can see how our crawler is working. So let's go to the browser again, and I'm gonna hit the rerun because we made some changes. Okay, so it is asking for us, since we are using the Selenium URL loader, we need to also install Selenium, of course. So let's go and put this in our requirements.txt and also run the pip command. So let's go back to the command line and say pip install Selenium. I'm gonna also add the index URL because my default is something else. doesn't matter. Okay, let's now run our web app again. Let's go back to Chrome. So we also missed another one, unstructured library, as I told you about. Let's also go back to here and install unstructured. Let's run our app again, go back to Chrome. I'm gonna go, for example, to Ollama Models, and let's say I'm gonna ask some question about this new Ollama model. I'm gonna post it here. I'm gonna hit enter and notice it's running. Don't expect it to be too fast, but it's also not that slow. So now that it's not running anymore, it's already loaded and it's ready to ask questions. Let's go to this text. It's saying, what is Llama? For example, this is interesting. Like, what are the supported languages for this model? I'm gonna ask it from it. These are our old tabs. Let's say, what are the supported languages in Llama 3.3? So as you can see, my question is here, and this is our answer. It's saying the supported languages are English, German, blah, blah, and also it's mentioning that you can fine-tune it for other languages, which is exactly what we expected. Amazing. Let's try also another website. For example, I'm gonna go to Martin Fowler's personal website, go to the About page and copy this link. I'm gonna go here, paste it here. Let's load everything. So after it is loaded, I'm gonna ask, who is Martin Fowler? This is my question, and this is the answer. It's saying that he's an author, a speaker, chief scientist at ThoughtWorks, and also like some of his publications. Everything is from the information that was provided to it here. So yeah, looks like it's working as expected. One thing to notice is that if you pasted some website here and your AI scraper is not working that great and it's saying, I don't know, or it's giving you some weird answers, you should work a little bit more on this load websites part. For example, I use this very simple Selenium loader from LangChain, but you might see that for some websites it's not extracting the information that great. Then you can build your own crawler using Selenium or Beautiful Soup or whatever tool that is out there, and then clean the text yourself. For example, you are seeing that LangChain is not giving you all of the text that is in this website. There is some problem. Then you will clean the text your way, extract the text your way, and it will definitely be improved. Also, please note that lots of famous websites like Amazon, LinkedIn, stuff like this doesn't allow crawler, and they will show you CAPTCHA. Some websites requires login. So to get data from those websites, either you need official APIs or much more complicated ways to crawl them. So yeah, that was it, guys. I hope you enjoyed watching this video. Please push the like button and also subscribe me for more content like this. See you around.